Hi, my name is Sean Jones, and I am the head of the Dark and Stormy Archives project. The Dark and Stormy Archives project tries to bring social media storytelling to web archives in order to try to summarize and expose information from web archive collections that might not be available through other methods. And today we're going to be talking about automatically generating story resources with Hypercane. Essentially, what gems will you discover in a web archive collection? And Hypercane is part of the DSA toolkit, which provides a series of tools for doing summarization and storytelling with web archives. The DSA toolkit provides a solution for each stage of the storytelling lifecycle. With step one, we can select the pages for the story. You can do it automatically with Hypercane, or people can do that. And step two, we can gather information to summarize each memento, each archived web page. And then in step three, we summarize all mementos together and publish the story. We've done a series of other videos talking about these other tools like Memento Embed, which gathers information to summarize each memento, or Raintail, which summarizes all mementos together. We're not going to be talking about those tools today. Today we're going to focus on Hypercane, which just automatically selects the pages for your story. There's also another video where we talk about installing these tools, and I invite you to watch that before you come back here. So please, if you haven't done that already, we won't be covering that in this video. We'll assume that you've already installed those tools. Also, if you're unfamiliar with storytelling with web archives, there is another video that gives you a nice introduction. So please go ahead and watch that and come back to this video when you have time. Hypercane provides intelligent sampling of web archive collections. It works with memento-compliant archives to discover mementos, and in some cases, it can even create new mementos if you need it to. And it provides reports on collection metadata, named entities, terms, and image analysis. And it's also able to provide different steps of summarization, and this is what we're going to look at today. Things like clustering, filtering, scoring, and ordering. And I discussed this in a little bit more detail in our introductory video, so please, if you haven't watched that, go ahead and look at that. And so that concludes the slide side or portion of this event. I've created a directory in my home directory called DSA tutorial. If you go into that, I've also created another directory inside there called Hypercane tutorial. And if you have not already installed Hypercane, you go to this particular URL. I will put that in the video later. You'll be able to see it bigger. And then there is a download Docker Compose file link at the top of the page. You right-click on that, save link as, and then navigate to your DSA tutorial folder and save it there. Now that you've done that, we can go over to the terminal, which I've opened here and made larger for you so that you can see much easier what's going on. Okay, so the first thing we're going to do is demonstrate how Hypercane can identify different aspects of an archivic collection. Now, Hypercane has a variety of different commands that you run, and because you're running it from Docker, using Docker Compose, you must preface each command with Docker Compose run, then the name of the container you want to start with, which is Hypercane, and then the actual Hypercane commands, which all are preceded by HC. I realize this is a lot to type, but this is the best way we've found in order to try to make sure that you have everything needed to run Hypercane. So if you do -- help, you can see it goes ahead and executes and gives you some examples and tells you what Hypercane is all about. There are a series of supported actions like sample, report, synthesize, identify, filter, cluster, score, and order. And all Hypercane commands take either a list of memento URLs, that is a list of archived web pages, or a list of time map URLs, or a list of live web URLs. And it allows you to convert those into other memento objects, like you can move from time maps to mementos and mementos to original resources or live web resources, and vice versa. There's a lot of capability here. One of the other things that you can do with it is you can specify an archivic collection as an input. So docker compose run hypercane HC, and we're going to use the identify command here. And we want to identify the time maps that exist in archivic collection 3649. And we're going to output that to a file named timemaps.tsv. So to explain this a little bit better, every Hypercane command takes the argument -i and -a. -i indicates the input type that you want to specify, whether it be archivate or mementos or time maps or original resources. There's also the ability to process content from the Australian Web Archive that we're working on right now. I won't get to that right here. Right now, we're going to focus on archivate. So we've supplied an argument of -i to indicate archivate is the type of collection, and that -a indicates the additional argument, in this case, the identifier for the collection, which is collection 3649, which is about the Boston Marathon bombing. And finally, we have -o, which specifies the output file and gives us, for output, we're going to output to a file named timemaps.tsv. We execute that. It goes ahead and runs. It tries to find archivic collection 3649 and downloads the appropriate content, scrapes a number of archivate pages in order to pull in pieces of information, and demonstrates how you can quickly acquire the list of time map URLs. Now, if we look at this list, I'm going to type the head command here, and we're just going to do the first maybe 20 lines of this file. And what we see here, actually, let me clear the screen so that's easier to see. What we see here is the file begins with URIT, which is the identifier term for the types of URIs that belong to time maps, and we have a list of URIs. So these are different time maps. If you visit these, you will see all of the mementos associated with a particular original resource. Like in this case, it belongs to abclocal.go.com. So the next thing we're going to do is we can also identify all of the mementos that exist in archivic collection 3649. What I've done here is we do HC, which is the Hypercane command, identify, which is how we get these different object types, and then mementos indicating what we want as output. We use -i to indicate the type of input, which is archivate. We use -a to indicate the additional argument, which is the archivic collection identifier. And then finally, -o indicates the name of the output file, in which case I just changed it to mementos.tsv. So we run that. And it takes a moment to go ahead and download everything and extract the mementos from the time maps and get the time maps from the archivic collection. So this is going to take a moment. Now I have gone ahead and already cached everything, so it should be relatively quick. We will see what happens here in a moment. Yes, there we go. It's all done. And in this particular case, the output is in a file named mementos.tsv. And we can run ahead and do just the first 20 lines on mementos.tsv. And we see that the first, the heading of the file is URI-M, which is the identifier for mementos. And we see the individual mementos in here for different captures of different pages. So these are different things that you can do with the identify command. We can also, let's say, we can type HC, identify, mementos, and instead of supplying archive it as an argument, we can do time maps as an argument. And then our input file could be that time maps file that we generated from before. And then our output file, I'm just going to name it mementos2.tsv, just to differentiate it from the one that we downloaded earlier. Now this will go through and grab all of the time maps, and then, or sorry, all the time maps that are listed in timemaps.tsv, and then it will try to fetch the mementos that exist inside those time maps, producing another list of memento URLs that we can use. And you see it's taking a moment because finding mementos takes a lot longer than just finding time maps. But the thing I'm trying to demonstrate here is that HC identify has a variety of ways in which you can convert from one memento object to another. HC identify help. So in the help, we see that there are time maps, mementos, original resources. We also support archive it, and we're adding support for Trove and other elements of the Australian Web Archive. So other things you can do with Hypercane is you can take an existing collection. Let's start off with our list of time maps. We can filter it to include only on-topic mementos. So again, Hypercane is the name of the command. Everything that comes before it is needed by Docker in order to execute it properly. Filter is the new action that we're supplying. Last time it was identify, now it's filter. We can include only on-topic mementos, and our input argument here is time maps because we're going to supply a list of time maps. Our argument for time maps is the file timemaps.tsv, which is the actual list of time maps. And then our output file here is going to be a file named onTopic-new. I go ahead and hit enter, and it starts executing. Now, trying to process and to determine if mementos are on or off topic is a whole subject into itself. I invite you to go ahead and read about the off-topic memento toolkit. I'll provide a link in the video. It should appear in a moment. And from there, you'll see that there's a variety of measures that we bring to bear in order to determine whether or not something is on or off topic. I discussed this more in the intro video because off-topic mementos could be 404s, soft 404s, 404s that do not actually return a 404. A page that says that it's no longer there. It could be a page that was hacked. It could be a page that is no longer on topic for the collection. But there's a variety of different reasons why something could be off topic. So it takes a while to process all these mementos. I've gone ahead and run this already, and I produced a file named onTopic.tsv, which we're going to use further, rather than waiting for that to finish. So our next thing we can do is to exclude duplicate mementos. And here we can run Docker compose again, and HC filter again is the name of the action. And we can exclude near duplicates from the list of mementos that were on topic for the collection. Now remember, like I said earlier, This is going to take a long time. In fact, I'm not going to let it finish. I'm just going to stop it. I'd run this before and already produced a file named onTopic.tsv just to save us some time. We're going to produce an output file of non-duplicates, and we hit enter. And what this is doing is it's going through and computing a mathematical feature for each memento known as a sim hash. And it's going to try to compare individual sim hashes to each other to find which documents are the same. And I have an example of that right here, provided by Al-Nomani in her work, where she demonstrated that there's a variety of similar mementos here in this picture. Everything that is in green is all the same content, and everything that is in red is all the same content. And the purple and blue are also different content. The point is that Web Archive collections, because of the way that they're constructed, are built by sampling and recording the same page over and over again a lot of times. And in that case, sometimes the page did not change. So we really don't want to create summaries based on the same page over and over and over again. Let's see if that has completed. And it says that output is saved to the file that we call non-duplicates. So we will go back and let me clear the screen so that we have some space to look at. We can type head and M20 and our non-duplicates file. And what we see in here is, again, a list of URIMs with URIM as the header. And so one of the things you're going to notice here with Hypercane is that we're essentially taking files that were output by some commands and inputting them into others. And this allows a lot of capability. We can go ahead and filter a list of mementos and then pass it through another filter again. And we can do a variety of other things as well. And that's the beauty of the way that it's structured. That's why everything is -A-I, and then whatever it is you want to do. So for our next command, we can filter again to include only languages, where the language is English. Let me clear the screen so this is a little bit clearer. HC filter. HC is Hypercane. Filter is the action. We include only languages, --lang to specify the language, en, then I, mementos, because we're going to use the file we generated the previous step, which contains mementos, A, non-duplicates, and then O, we're going to name the output file English only.tsv. We hit enter. And this is processing our non-duplicates file, trying to figure out what languages are for all of the different mementos that were there, and only keeping the ones that were English. Now, we're not actually removing things from the collection. I want to stress that. We are only filtering the input that we received and excluding things and just returning a list of identifiers. So here, our output file was English only.tsv. We see, again, it is a list of URIMs. It is just a list of memento URLs that you can then pass to another command. So that is the last filter that I'm going to demonstrate, but you can always get to Hypercane's help by typing HC, of course, the name of the command, and then the action you want to help on, and then help. Whoops, not help-o, help. And HC filter includes include only and exclude. So you can exclude based on a variety of things as well. So we can get help on include only and find out what actions are available there. does help if I add dash dash help. There we go. So we see that, let me try that again so it's clear. We see that we can include only certain languages. We can include only non-duplicates, which is the reverse of excluding near duplicates. We can include only on topic. We can include only the highest score per cluster after clustering, and we'll get to clustering in the next step. We can include only mementos that contain a particular pattern or are near a particular date time to supply a date range in order to filter the collection. We can also include only mementos that contain a given URL pattern, or we can include only mementos from the largest cluster or the top 2 or 3 clusters. Maybe we've done some clustering and we want to only retain the clusters that were the largest for the collection. There are a variety of different things that we can do here with filter. And of course, we also, with filter, have exclude. Now, filter is the only command that has additional actions underneath it like that, whereas include or exclude. Now, exclude, we can only exclude based on languages. We can exclude off topic. As we demonstrated earlier, we can exclude near duplicates. And then we can exclude those that contain a particular pattern. And of course, we're expanding these options all the time. So the next thing we're going to demonstrate is running Hypercane, HC, and there's another command named cluster. And with cluster, we have a variety of ways we can cluster, and we're adding new ones often. The first one we're going to use is from Al-Numani's algorithm. It's a time slice, and we're going to take in a list of mementos that are found in the file English only, and we're going to output it to a file named sliced. Now what this will do is take the mementos that it finds, find their capture date times, find their memento date times, and then organize them into individual slices, individual buckets based on those date times. And this is important for summarization because we want to make sure that we represent different time periods that the Web Archive collection might have collected from. Web Archive collections may span weeks or years, and it would be a poor summary to just give you a sampling of mementos that are all from 1 year when, say, a particular collection spans 7. So we run this clustering algorithm. It goes through and parses and extracts the memento date time, and now it's done. As you can see, some of these things execute relatively quickly after you've already run this once or twice because the content is cached. So this produces a file named sliced.tsv. Clear the screen so we can see this better. Sorry, head-n20 sliced.tsv. So we're just going to take the top 20 lines. And so this is a slightly different output format. Now, it still can be used with any Hypercane command, but in this particular case, we have 2 fields in this file. It's tab separated. We have a URIM, and we have the cluster it was assigned to based on the slicing. And so we see numbers like 15 and 12 and 10 over here on the right. And that was the cluster that was assigned to that particular URIM based on the time period that it came from in the collection. But that is not the only type of clustering we can do. We can also HC cluster. We can also execute the dbScan algorithm with a few restricted features on the collection. So we can make the feature maybe the term frequency sim hash of each thing, of each memento, and then load a set of mementos. And our argument for that is the file named sliced. And we're going to output to a file named sliced and clustered. I hit enter, and it's taking in that file that we generated in the last step and clustering again based off of the sim hash of each document. And it's clustering them together based on how close they are to each other in terms of similarity of their content. And the beauty of this is that you combine the slicing with the clustering, and you end up with novel mementos for your story or summarization. Okay, so it says the clustering of the collection via dbScan on this feature sim hash is complete. Output to sliced and clustered.tsv. Let's take a look at that. Just the first 20 items. And what we see here is the same headings of URIM and cluster, but instead of just the one identifier for the cluster, we also have now for the time slice, we also have a new cluster identifier, which in this case just happens to be a bunch of zeros in this top here. So these 3 tildes in between the 15 and the 0 are supposed to separate it so that you can see that this was, the first cluster was 15 and the second was 0 from the clustering. And you can repeat this over and over again with a number of different clustering algorithms. So one of the things that you can do here is Docker compose, run Hypercane. Let me clear the screen first. Docker compose, run Hypercane HC cluster --help. And what we see here is a variety of different ways to cluster. We could cluster based on time slice, like I described before. We can use the dbScan algorithm. We can cluster based on latent Dirichlet allocation, which is topic modeling, essentially splitting the collection into individual topics. We can use k-means clustering instead of dbScan. It's another clustering algorithm. And we can cluster based on the domain name. So if there's a particular set of domains that exist in the collection, you can put all of the CNN.coms into one cluster and all of the FoxNews.coms into another cluster. And the goal there is to make sure that each is represented in the final summary, if that is what you're trying to do. And of course, we also provide some examples here of different things that you could run. Once you have your cluster, we can move on to the next thing, and we have scoring. So the Hypercane command HC score, we're going to do DSA1 scoring with -I mementos, -A sliced and clustered is the name of the file we produced from the last step. -O scored is the output file that we're going to create. And here we're going to execute the score action. The scoring function we're going to use is DSA1 scoring. This is the scoring function that Al-Numani had developed, which scores each memento based on how long the URI is in terms of how many slashes it contains. It also weights that along with the type of content it is, whether it's news or social media. And additionally, it can leverage memento damage, which I went over in our introductory video. But the memento damage essentially is how much content is missing from a given memento. I'm sure we've seen them in web archives where we have a particular page that just doesn't have images, or there's something wrong with the style sheet. But we're not going to use memento damage today because that's a very long process. So right now we're just using the other elements of Al-Numani's algorithm. Memento damage requires an entire other server and other processes to run, and we're just not going to do that. So what this will do is it'll detect that it can't find that server, and it will just score based on the category that the content belongs to, as well as how long the URI is, its path depth. It runs, it's going through, it's producing a score result for each one, and our output is in a file named scored.tsv. And because we've been iterating and using these files over and over again, we've been kind of building on each other, and Hypercane does not destroy the content from the previous run. So what you see here is your different fields in this file. URIM, we have the cluster, and then we have rank, and we have DSA1 score as the type of scoring that we're doing. And what we see here is we have the URIM, and then a tab, and then the clusters that it belongs to based on off of what we ran before, and then its score based on Anumani's scoring function. And these scores are very important because this is how we're going to determine which mementos get promoted out of each cluster for our summarization. So we're going to clear the screen, and I will show you that we're not, of course, limited to just DSA1 scoring. There are a variety of other scoring actions that are available. There's DSA1 scoring. We can score based on BM25, which requires that you supply some sort of input query, and it will evaluate each memento based on how well it matches that particular query. And we can also score based on the number of images in each document. And we're adding new scoring functions as time goes on. So to demonstrate how you can feed this back in further, we're going to run HC filter again, but include only the highest score per cluster, where the input is mementos, the input file is our scored file from the last step, and our output would be highest scored.tsv. So we go ahead and hit enter, and this examines the cluster information, examines the scores, and promotes the highest scoring memento from each cluster. So our output is in well, I didn't spell it correctly, but highest scored.tsv. If we look at that particular output file, just the top 20 lines, we see that it's not ordered quite the same at all, but there's no new headers. All this has done is it's filtered and reduced the number of mementos that exist. So if we look at the individual files that we've been producing, we'll see that there are, in the full collection about the Boston Marathon bombing, there are 2,309 mementos. 1,769 are on topic. 425 are not duplicates. 422 are English. Now the slicing and clustering outputs don't change the size at all, so I'm not going to look at those. I mean, if you look at sliced, it's still 422 mementos because it's just applying the slice assignments to the individual mementos. But if we go ahead and look at what our output from the last command, where we reduced based on the scoring, we see we only have 22 left. And these 22 mementos will be the ones that make it into our summary. Now, the last step that's important for summarization is to order. Now, you may not care about this for your particular collection. It might not matter. It may not matter for the story you're trying to tell. But in many cases, one wants to order their individual items by their publication date or capture date. And so we're going to run our final Hypercane command today of order. We can order by publication date, which we use by pub date, where we type pub date, else memento date time. And then we take an input argument of mementos found in the highest scored file that we produced there, and we output to a file named ordered. We type enter, and what it's going to do is try to find the publication date for each of these mementos. If it cannot find that, it'll fall back to the date that it was captured. It's memento date time. And we see that the output is in a file named ordered.tsv. We look at ordered.tsv. We see, again, it has retained the clustering and ranking and everything from the previous runs. However, if we look at the number of mementos we had from our highest scored, and we look at the number of mementos from what we just ordered, we see it's exactly the same number. And the point is that we didn't actually remove anything, we just rearranged the mementos in a different order. And so with ordered.tsv, we can now visualize our story. And if you want to talk about that further, I invite you to go ahead and watch our Raintail video where we discuss how to take this list of mementos and produce stories like this. This is not for the same collection, but Raintail can convert that list of mementos into something more beautiful like this, including pictures and images and other things. And we'll talk more about the other things that you can do with Hypercane at a later time. But as a preview, remember that you can run --help at any point. And you can see the list of supported actions. We went over identify, filter, cluster, score, and order. But if you want to run a pre-existing algorithm, you can run sample. And sample supports Al-Nomani's complete algorithm, which is what we just worked through. We worked through Al-Nomani's algorithm fully. You can also run true random, where it just randomly selects mementos, or filtered random, where it will filter near duplicates and filter off topic mementos and then sample K from the remainder. There's also report, which provides a variety of reports on different aspects of the collection, such as metadata, image data, terms, entities, seed statistics, and growth. So, for example, if we wanted to do Docker compose run Hypercane HC report growth --help, we see that we have a variety of options for this. We can take in an input file or an input argument of archive it and a collection of, I believe it was 3649, and output a bunch of statistics to a file named 3649 growth stats. I'm going to name it .dat for now. And we can also supply another argument, -- growth curve file, to this, and do 3649 growth curve .png. We run this, and what it's doing is it's going through and analyzing the collection to find the time maps, when the individual mementos were collected, when the individual items were gathered, when they were first crawled, and it's producing a report based on that we can use in order to try to understand the collection. And our growth stats are saved to a file named 3649 growth stats. So if we clear and then cat 36, 3649 growth stats. We see a JSON. We see JSON output containing a variety of different statistics for the lifespan of this collection, its first memento date time, its last memento date time, all kinds of things like that. But also interesting is 3649 growth curve. And that is in the same directory. So what we'll do is we will open it here. And we see this is how the collection grew over time. We see that a lot of the original resources and a lot of the mementos were added early on in this particular collection about the Boston Marathon bombing, probably within hours of it occurring. And then sometime later, somebody added some more. As you see, the green and red lines are plateauing and then rise a little bit. And then eventually the collection approaches 100% completion toward the top, towards maybe the 60% element of its life. And if you want to find more information about these particular graphs, I invite you to read our paper titled The Many Shapes of Archivate, which covers this, and the link will appear right now in the video. So that is an overview of Hypercane and the different things that you can do with it, how to run it. You can produce a number of different files that all contain lists of memento URLs or time map URLs or other things. And then from there, you can just run wild. You can summarize your collection however you see fit. My PhD dissertation is about summarizing using a variety of different algorithms. We just went through Al-Nomani's algorithm. And if you would like to complete these exercises in written form, they're available here. And I will provide this URL in the video. You'll see it above in a moment. And what we do here is exactly what we did today. We're going to iterate going through Al-Nomani's algorithm with these different commands that we typed right in front of you. So you can look at excluding by language, slicing by date time, clustering mementos in each slice, choosing the high quality pages, using the scoring function. There are a variety of things here, but this is just a little bit of what Hypercane can do. Also, if you want to find more information about Hypercane, we do have some documentation that you can find off of Hypercane's main page, but it is incomplete at the moment. So I suggest that if you want to read more about it, we wrote a series of blog posts that have a ton of information on Hypercane's capabilities, including just doing intelligent sampling of various web archive collections and how Hypercane fits into the overall storytelling and summarization work that we're doing. We also show here the growth curves that you can output and export. And then we have Hypercane, the second blog post, covers how to combine it with other tools, like Raintail for storytelling, or Archives Unleashed Toolkit, or GenSim for topic modeling. And there's a variety of different things that you can do with this. Like for topic modeling, you can produce word clouds conveying what an individual collection is about and what individual topics within the collection might contain. In this case, this collection was all about COVID-19. And then our final part of Hypercane is to supply you with information about the individual primitives that we went over briefly today: identify, filter, cluster, score, and order. And that's how you can build your own algorithms. So if you have any questions, please contact us and we'll be happy to answer them. I thank you for watching our video and have a nice day.